Hi folks, Mr. Ackerman here. Thanks for watching. The topic of this video is the lab for Unit 2, Accelerated Frames of Reference. If you go to page 12 in the course pack, you'll find a rubric which shows you what I'm looking for you to hand in. However, the document that you see here does not talk about the entire lab, and that is important. Otherwise, you're going to have a hard time figuring out what to hand in. So I'm going to leave this for a moment, and I'm going to jump into the textbook to section 2.5, which is where the topic of inertial and non-inertial frames of reference or accelerated frames of reference was introduced. You'll recall in class, we talked about the two different kinds of frames of reference that you never knew existed up until now. And we also talked about these strange forces called fictitious forces. We drew free body diagrams, and we even did a sample problem. It was this one right here, sample problem 2 on 109, which has as its base scenario a mass hanging from a string from the ceiling of a bus, which is accelerating. And due to the acceleration, the mass hangs at an angle. And the question is there a formula that can relate the angle to the amount of acceleration? Well, according to the math that you do here, we were able to derive an equation, A equals g tan theta. I call this the accelerometer equation. And the topic of the lab, its objective, is to determine whether or not this equation is valid. So we're going to somehow accelerate a pendulum, and we're going to measure the angle, and we're going to use some independent method of gauging acceleration, and we're going to compare the two to see whether the results are similar. And if so, maybe we can conclude that the formula works. And if they're very different, then maybe we made a mistake, or maybe this formula is just not correct. So at this point, what I've done for you, since many of you, depending on the semester and the rotation, are not face-to-face, what I've done is I've run the lab in class. I've filmed it from various perspectives, and I'm going to show you the lab as you would have seen it if you were there. And if you were there face-to-face, then this is a good review because you can't just drop in whenever you want. So at this point, I'm going to take a break from talking. The video I made, which is going to play right in this video coming up next, is 4.5 minutes long. So keep playing. Here it comes. After it's done, we will reconvene and discuss. Welcome back, folks. So at this point, you've been able to see what the lab looks like, especially if you were not face-to-face. Now you know exactly what I'm talking about, I hope. And you got to see us state the objective of checking whether the accelerometer formula gives the correct result for the acceleration in a non-inertial frame of reference. And you saw the results compared with the motion sensor, and I think we got pretty good results. The thing that I'd like you to do now, after you've analyzed the results and made your conclusions, is the following. Take a look back at the rubric and make very careful note of this. I only want you to hand in the following items. I do not want you to hand in anything more. It will not help your mark. In fact, it might actually hurt it because it would mean you're not reading the instructions carefully. And I also don't want you to do extra work that you're not going to receive credit for. So, what are the two things? The first thing is called an introduction. In a lab report, the introduction is the starting point where you state your objective and you provide the reader with the necessary background physics knowledge that he or she needs to understand what you did. Now, it doesn't mean you have to reteach all physics leading up to this point. Things like vector components, Newton's laws, kinematics, things that we all understand, that we all know from our past, you don't have to explain those. But anything new that relates to this lab, you do have to explain. If you take a look back in the textbook, you'll see the way that one author explains it. The author of your textbook does the following. He uses sentences, he refers to diagrams, and then you find the diagram very close to where it was referred to. You find a figure number and caption, a description of what's in the diagram, and then the writing continues, and so on. Any important words are defined, any important terms, and so on. If it's a concept that relies on mathematics, like it does here, you may see a sample problem or a derivation. This one involves a free body diagram. We have a look at the forces, we do a little bit of math, and we come down to the accelerometer equation, which is what's being investigated in this lab. So these are all good things to include, and this format would be very good to use as well. However, do not, I repeat, do not copy exactly what your textbook does, or any other textbook for that matter. You need to think for yourself, show that you understand the concepts by creating an original work, including something with your own diagrams. Do not copy and paste or screenshot other diagrams that you found on the internet. Do not share them with other people in the class. This is your work individually, all original material, okay? Going back to the rubric, you'll see a rundown of the things I just discussed. And if you want, there's a link here to a first-year university physics lab that is it's online here. They've given an example. If you turn to page 4 to 5, you'll see many of the same things that I just discussed in another example, okay? This is going to be marked for communication and knowledge and understanding. It says C rubric, which is on the next page. If we scroll down, you'll see for the introduction, KU 5 marks. To get a level 4, do the following. Include all relevant physics ideas and present them correctly without mistakes. Also state the objective of the lab very accurately and efficiently. In other words, not using sentence after sentence after sentence. Just try to give a succinct statement of the objective. In terms of communication, also 5 marks. I'm looking for the following for a level 4. That you include all the relevant physics ideas and you clearly express them in writing, so in proper English, proper sentence structure, paragraphs, and so on. You clearly express them in symbols and equations wherever appropriate. And you clearly express them in diagrams, which includes captions, figure numbers, any labels, you know, the kind of things we do when we solve problems in class or on a test. Same thing there. Do all of these and get yourself a level 4. The second thing I'd like you to hand in is called the apparatus and procedure section. As the name suggests, I would like a list of the materials that need to be used or gathered to do this lab. And I'd also like a procedure for how to carry it out to get the results that we got. So in terms of the apparatus section, that can simply be a list. The way a recipe for food that you might be using also has a list of ingredients. And the procedure section should have something like step 1, step 2, telling somebody what to do to replicate your results. Basically, when I read this, I'm going to pretend that I'm a grade 12 physics student from another school, and I'm going to ask myself, could I follow along here, walking into Thornley from some other school, and repeat what these guys did in class? If yes, great. If no, not great. So maybe have someone read it over to check whether things make sense before you hand it in. The other thing that I'm going to be looking for is whether the procedure that you've laid out is scientifically valid. So I'll give you an idea of what that means. If you think back to the lab that we did back in grade 11 on acceleration due to gravity, do you remember how you did that? You probably took a mass and you probably attached it to what's called a ticker tape, and you might have run it through the spark timer or the ticker tape machine. And it made little dots on it, and you measured them, and it gave you an idea of the acceleration of the mass, and you were able to conclude what the acceleration due to gravity was. Well, imagine if you wrote something like, take an object and drop it through the spark timer with ticker tape. If you didn't tell me what kind of object, I might pick up something like a ping pong ball. A ping pong ball is really light, and it falls at terminal speed much, much sooner than, let's say, a 200-gram mass that we might use in this lab. As a result of not specifically telling me what kind of object to use, I might use an object which is going to yield results that don't answer the question, what is acceleration due to gravity? In this case, you've given me a procedure that's not going to produce scientifically valid results. And so in a similar way, when you think of this lab here, accelerated frames of reference, think to yourself, are there any kind of hidden pitfalls here where if I don't tell the reader exactly what I'm looking for and exactly what to use, he or she is going to get conflicting results or invalid results? I don't want to tell you what they are, but if you watched the video just prior to this, where you saw the lab being carried out, there were some pretty strong hints in there, and you can use your thinking skills to find the other ones that I didn't mention. Okay? Moving down, how are you going to be marked for this section? You'll be marked for thinking, 10 marks. This is basically where you're making sure that everything that needs to get done for a scientifically valid result does get done. Include all the steps needed so a grade 12 student from another school could follow along and execute this lab the way you did, and make sure it's scientifically valid. In terms of communication, once again, words, diagrams, and photos are necessary. Now, I know that a lot of you are not face-to-face necessarily when this is being presented, and so you may not have the luxury of being in the lab and being able to see the apparatus up close. So what I'm going to do is, since I've given you the option here of using photos instead of having to make diagrams for the setup, I've taken some photos and I'm going to post those as JPEGs in the Google Classroom assignment. You are invited to use them if you wish. I'm allowing you to plagiarize or to copy me. Well, it's not plagiarism because I'm giving you copyright permission, let's call it, so that you can make up your procedure with actual photos of the equipment, and then all you have to do is make figure number and caption when you include those in your write-up, okay? If you, however, wish to make diagrams of your own, or if somehow you have access to lab equipment, or maybe you're face-to-face and you want to take your own photos, you are invited to do that as well. And so that's it. These are the two things I'd like you to hand in. How long is this whole thing going to be? I would think you can get the introduction done probably in 1 page typed. I don't think it should take any longer than that. And I would think the same thing for apparatus and procedure, maybe 2 pages if there's a lot of pictures that take up a lot of space. Same thing for the introduction. Maybe it'll take 2 pages if there's a lot of diagrams that take up a lot of space. But I highly doubt any more than 2 pages here and 2 pages here, probably less. Okay? That's it for now. If you have questions, you know how to get a hold of me. I look forward to reading your labs, and good luck. See you soon. Bye for now.